Okay, I can start. And my name is Sofia Konikova, and today I want to present problem number 14, problem rising in the bulk. Let's remember the problem statement. We have vessel that's shaken appropriately, and if we place at the bottom some body, it will rising up. So we need to explain the phenomenon and create the device with the most energy efficient shaking technique. So sorry. Firstly, we need to create a vibration surface. We need to create a vibration surface for somehow. First, we need to create a vibration surface for first observations. It consists of a vessel fastening, vibration surface, springs, motor with eccentric, and cable. So you can see how it looks in real life. So after that, we need to clarify vibration. We need to clarify vibration type. We believe that it is sine signal, and for and we need to prove it. And we need to prove it. We use oscilloscope and Arduino accelerometer to understand what vibration type is that. So we can get closer image of it, and we need to understand is it sine or not. So we can make fast Fourier transform, and as we see only one mean peak, and it means that we have a sine signal with good accuracy. After that, we can make first observation of the process, and as you see, the ball rising. So the main point is to detect the position of the ball, and for that we use stick. We use stick, and we track stick coordinate, and also we need to limit the freedom degree and estimate stick influence of rising process on rising process. For that, we, as we see, the highest time measurement error is about 1 second, and it's extremely small for us. So you can see my outline. Firstly, we need to understand rising mechanism in one period of ball motion, and understand sand behavior in this one period. Of course, we need to quantitative explain it, and make the experimental proofs of it. So let's try to qualitative explain.
Excuse me, maybe just before you start, yeah, so just make sure to try and explain everything in about 7-8 minutes, so people can also then present. Did you understand me?
Okay. Okay.
Then you can have 1 or 2 questions. Okay, thanks.
So firstly, we need stable system, and then the vibration surface moves up. The sand and the ball start to move up too. So when the sand goes down with the system, with the vibration system under action of the friction force, but the ball moves up by inertia relative to the table. So after that, cavity under the ball forms, and we can see a cavity after cavity under balls falls. And as you can see, we see small cavity under the ball, but we can't see the second part because we have imperfections of 2D conditions. So then the sand particles starts to fill cavity space, to fill free cavity space, and the ball is stopped by the surface by the force of resistance of the sand, and it starts to fall. So the ball falls on the surface, and important thing is that not all volume of the cavity is filling in the end of the process. So we can see experimentally that the cavity is filling during this process, and also we can see it from video. Our qualitative explanation is proved in article, and as you can see, the track motion of ball in one period is something like jump and fall. So it confirms our explanation. So we describe rising mechanism, and now we need to theoretically describe this. So we need to write Jensen's equation. It's about distribution of pressures in the sand. It exists because we have some weight distribution from upper particles to lower particles. We can write second Newton's law for it and calculate vertical pressure depending on coordinate. And as you can see, when we have external force and we have no external force, there is a difference about 5%. And we can assume that it is small error and small error. So we need to determine Jensen's coefficient. We need to determine Jensen's coefficient, and as you can see, the coefficient goes to a constant, but in solution we use interpolation for good accuracy. And on slide you can see how vertical pressure distribution changes. So after that, we need to describe horizontal forces, and also we can write second Newton's law for it and calculate horizontal pressure distributions, horizontal force distributions. And as you can see, radial force increases towards the walls, and it confirms that. It confirms our qualitative explanation. So after that, we need to go to quantitative part. We can write second Newton's law for our ball, and the ball trajectory is something like parabola. And after that, we need to calculate sand filling in cavity filling. For it, we write second Newton's law with filling coefficient. It's something like continuity equation. The calculation of its equation you can see on slide. So the intersection point is point where ball falls into the cavity, and after that balls move with vibration surface. And the ball trajectory is something like a combination of jumps. So after that, we need to experimentally prove our theory. So we can see good agreement we can see good agreement of theory and experiment. Can see good agreement experiment. Good agreement. And we need to make some parametric investigation. You can see rising time depending on sand height. Also, we have good agreement, but in last part, we see something like big errors, and we can explain it another dimensional shaking effect. So the most important part of this work is plot a rising time depending on density. We can see three parts of the process. It's first part, it's about horizontal shaking. Second part, it's convection inhibition, and the third part is cavity filling. As you can see, cavity filling process is described. It has good agreement. So and also we need to create shaking technique optimization. Shaking technique optimization, the surface of the sand should catch up with the ball at the top of the lift, and at the top of the ball's rise, a new impact must occur. So we need to create a vibration table, something like that. And as you can see, theoretically, rising time in decreasing so much, and so it is our optimization. Thanks for your attention.